Good day, everyone, and welcome to another installment in HORIBA's webinar series. Today's topic, the GA-370 trace gas analyzers. My name is Lance Cizik. I'm the Western Regional Sales Manager. Myself, along with Mick Dolan-Mayer, the Eastern Regional Sales Manager, and Norio Kobayashi, our product specialist for North America. We are your sales team. A few items to cover quickly here before we get started. We are all over social media. We are on all the platforms. We would ask that you please go to YouTube, search for HORIBA Process and Environmental, and this webinar, once it's been completed, will be uploaded along with all the other webinars that we've done over the past few weeks and months. They're all there for your viewing. So we ask that you please go check us out there. We're also on all the other platforms, Instagram, Twitter, Facebook, and LinkedIn. So track us down, like us, follow us, tweet to us. We're up for it. There's an awful lot of content that our marketing manager, Stevie Lee, posts on those, so lots of good information there. A brief agenda of what's going to happen and what you can expect today. I'm going to spend a little time going over who is HORIBA, where did we come from, where are we now. We'll talk a little bit about the Houston facility. We'll briefly touch on the products that the Process and Environmental Division offers, and then I'll pass it over to Norio Kobayashi, and he'll dive a little deeper into the GA-370. At the end, we'll have a Q&A. So what I'd like to ask you to do is, if you do have questions throughout the course of today's presentation, please enter them into the chat box. Those will be proctored, and once we have finished with today's presentation, I'll read those questions off to Norio, and we'll try our best to answer them. If we can't answer them, then we will certainly get back to you with that information, whether it's me, Mick, or from Norio. So without further ado, who is HORIBA? Well, we were founded in 1953. We're headquartered in Kyoto, Japan. And overall, we are, by design, offering products for analysis and measurement technology. Since that time, we've grown to about 7,200 employees out of 49 global locations. In 2019, we did just a little over 1.8 billion in sales. So where does that 1.8 billion come from? Well, there's five different divisions under the HORIBA umbrella. There's the automotive test systems. There's the process and environmental, obviously that's ours, which also includes water quality. We have the medical, we have the semiconductor, and we have the scientific division. So all of these divisions, they all make up the company that you know as HORIBA. Specifically to the Americas, you can see here, these are all of our sites in both North and South America. For the Process and Environmental Division, we are specifically located in Irvine, California. We have some project management and admin is all handled out there. And then we have our new office that we opened back in 2018 in Pasadena. If you're not familiar with Pasadena, it's a suburb of Houston, just a little bit southeast. So we're very close to quite a few of the major petrochemical players down there. A bit more detail about the HORIBA Houston facility, HORIBA Pasadena. It was originally founded back in 1985 by Cameron Process. We purchased it in 2012 and opened this shiny new building back in 2018. It houses 100% HORIBA employees. And who are those employees? They are CAD designers, project managers, electricians, mechanical engineers, manufacturing, inside sales. Norio's office is actually in this building, so quite a bit happens. We're very happy about the manufacturing capability as it stands now, with the exception of the PG portable analyzer, which was also one of our webinar series topics. All of our products are now manufactured out of the Houston office, so we're very happy about that. Some general overviews as far as what some of the capabilities are from our Houston facility. We can do analyzer shelters, we can do analyzer racks, analyzer enclosures. We've got quite a bit of flexibility from that perspective. That's all the way from engineering, design, fabrication, to project documentation, installation, commissioning, you name it, we have experience doing it. We offer field service and embedded service contracts. So if you need a preventive maintenance call, or if you need support, we can certainly offer that. And if you have multiple HORIBA units, we can obviously explore the opportunities as far as having embedded service personnel at your facility to make sure that those analyzers are up and running on a consistent basis. We also offer RADA testing. If you have any questions about that, please feel free to reach out to Mick or myself, and we'll be happy to have that discussion with you. Some more specifics about the Houston facility. Our capacity there is about 30,000 square feet. Gives us the ability to put about 22 shelters, each being about 10 by 20 by 9 inside a climate controlled environment with room for 8 additional shelters of the same size outdoor in a covered testing area. So we've got plenty of space for everybody. If you decide you want multiple shelters, or if we have multiple projects going on at the same time, we have more than enough room for us to do that. Some of the capabilities that happen inside the shop: sample conditioning system construction. We have rack construction, enclosure construction, process electrical and mechanical integration, HORIBA analyzer integration, obviously. But I think a little known topic is our ability to integrate non-HORIBA analyzers. If you have an analyzer, say you have a GC, or you have a mass spec, or a turbidity or opacity, if you have one of those analyzers and you need to put into a shelter or enclosure, we have the experience to be able to do that. We've done it with multiple different vendors. And so if you have a need for that, please reach out to Mick or myself, and we'll be happy to help coordinate that with you. The products that we offer, obviously, there's the process gas analyzers, which is the GA-370, the topic for today. We have ambient air monitors, process gas analyzer as well, the VA5000, the multi-gas analyzer. That was also one of our webinar series topics. Go to our YouTube page. The PG300, our portable gas analyzer, also on the YouTube page. You'll find that webinar. The flagship of all of our gas analyzers, our SIMS unit, the NDIR 7000, and then the particulate monitor, the PX375. Again, there are webinars on the VA5000, the PG, the ENDA, and the PX already up on our YouTube channel. If you'd like to go back, you can certainly go check those out at your leisure. And then once we get things finished today, we will upload the GA-370 presentation for your viewing at that time. So again, if you have any questions, please do enter those into the chat box. They will be proctored, and I will ask those questions to Norio at the end of the conversation. So that being said, I'll pass it over to Norio.
All right, thanks, Lance. Good morning, everyone. My name is Norio Kobayashi. I am a product specialist with HORIBA. I've been with HORIBA for about 15 years, and from Japan, and transferred in the US and working for US for 6 years. Today I am so happy to explain, to show you the introduction of the GA-370, which is the trace gas monitor. And here is today's outline, the product overview, and the applications, and why GA-370 is recommended to those applications. The picture on the left is showing the outline of the GA-370. The simple front panel has touch panel screen there, and if you have if you have experience with the VA5000 or PG350 or GI700 analyzer, all of the operation system is almost the same. So that's the idea to go to manipulate all of the menus. GA-370 can measure up to 2 parameters by 1 unit, and you can select the measurement, the parameters from CO, CO2, CH4 methane, N2O, and siloxane. GA-370 uses patented dual cross-flow modulation technology, which I explain later, but this helped contributed a lot for the lower concentration measurement. Variety of the background gas like nitrogen, air, helium, hydrogen, O2, or argon is applicable. Excuse me. Yeah, GA-370 has a ultra high sensitivity, and you can set the range at 1 ppm as a lowest range. And even you set such a lowest range, you still have a great stability. For the drift, we guarantee plus minus 0.03 ppm per week. And the lowest detection limit is also really insane level. It is 10 ppb. Probably it is world lowest range ever in NDIR. GA-370 has the great touch panel interface. As you can see, the measurement display is right here. It shows you up to 2 parameters, the measurement range, measurement value right here, and the range is showing right here on the side. If you go to the click to the menu button, and then you can open that with menus icon right there. By touching this, you can go to the each functions. In a part, in a menu icon, menu page, there are parts management, analog input, output, even event history is right there. If you go to the event history, you can see that what's going on, what event happened to these analyzers in the past. And also you can get the information about the right time to replace the consumable parts. Although a GA-370 doesn't have many consumable parts, but still the filter need to be replaced in the frequent time. And it's showing the filter has a lifetime. The 365 days can be used for it, and you have already been using for, in this case, 0 day or 2 days, 5 days, or 10 days. It's telling you how many days you have been using for. And this is the calibration mode. You do the calibration for each the parameters, and the zero calibration for both parameters. So that's how it works. So it's simple interface, and show you friendly guidance, and that will just need a couple of hours to know everything in there. So it's a great interface to learn the things. All right. Next page is showing the comparison table compared with the other companies one. As you can see, the GA can pick from many selections like CO, CO2, the CH4, N2O, SO2, and siloxane, while the other has the little, fewer selections. And also you can measure up to 2 parameters, while the other is measuring only 1 parameter, so which is great advantage. What you need for the operation is reference gas. You will need to prepare the pure nitrogen or instrument air, clean instrument air. If it's not that enough clean, we can prepare some purifier unit, so we can clean it up to produce reference gas. The range setting, you have the 1, 2, 3, 4 range settings right there, from 1 ppm and 2 ppm, 5 ppm, 10 ppm. So you can have multiple ranges there. And when you look at the repeatability or linearity, you can see that plus minus 0.02 ppm, which is very, very good compared with the others, like 0.1 ppm or plus minus 0.1% full scale. So that is the great performance here. And for the drift, when you look at the zero drift and the span drift, it says plus minus 0.03 ppm per week. So that means you will get the stable measurement for a week, which means you can do that for continuous measurement purpose. So that's the the main features of the GA-370 has the great capability to do that for the trace gas monitoring. All right, let's talk about some applications. Air separation unit, uh, cryogenic air separation process. They use the differences in boiling points of the components to separate air into the desired product oxygen, like oxygen or nitrogen or argon. So they just put the air and separates the components inside, and extract the necessary the components to produce their products. These three gases like oxygen, nitrogen, argon represent about 99% of the dry ambient air. Nitrogen would be about the 78%, and oxygen would be about 21%, and argon would be about the 0.9%. The rest of the other gas must be removed properly in the air separation process. The target components will be, water vapor and carbon dioxide and hydrocarbons. Um, the reason why we need to remove those is because to ensure safety or efficient plant operation and the product purity. We want to keep eyes on each important points. Make sure that those other gas has been already removed well. So that is the role of the trace gas analyzer. Again, the role of the trace gas analyzer is making sure each process worked well. Before you go to the next process or final product stream, you want to make sure um, its quality is good enough to go to the next stage. If it's not enough, then you will need another round of the process. This will sacrifice a lot of energy, cost, and time. So, the monitoring the each point is contributing the proper operations. Let's go to the more deeper about air separation. So this is the rough sketch of the separation unit process. The ambient air, is going through the filter and capture all of the dust in the ambient air. And air is and then compressed and going through a molecular sieve process to remove H2O and CO2. Because if the forward process contains those H2O and CO2, the formation of ice or dry ice may occur in the cooling process. The cold box inside is going to chill the air at the minus 173 degrees C. It's extremely cold. So before entering a cold box, you want to remove H2O and CO2 completely. So now I guess you understand why monitoring CO2 with high sensitivity is extremely important to do this. Because CO2 in air has to be zero. Then the cold air goes to a distillation process, and your gas is going to be chilled more. And at each point in the distillation process, uh, the gas comes off the product streams, and nitrogen gas and argon gas and oxygen gas. Each different point comes off the each product streams. Um, and you want to check each point, make sure that your purity is good enough for your product. You may want to CO2 in a nitrogen base. You want to make sure that CO2 methane in argon product. You want to make sure that O2 purity by measuring the CO2 and the methane. So that's how you are monitoring the gas of those products. Here's a more explanation of each sampling point for trace gas monitoring. The trace CO2 measurement before this the cold box process, like I explained, the CO2 needs to be removed from the feeding air prior to introduction to the cold box process. Also, you may want to monitor after cold box process to see the efficiency of the heat exchangers. So typically, the CO2 is monitored in this process is from 0 to the 10 ppm ranges. The CO2 and the CH4 is monitored in O2 product streams right there. And the CO2 is especially unwanted components in the product streams because of the oxidizing potential. And the typical measurement range at this point is 0 to 1 ppm, and some point could be maybe 10 ppm. Another trace CO2 and the CH4 measurement in argon product streams, right there, is typical measurement range is 0 to 1 ppm. So you are required to measure extremely low concentration, low concentration control at this point. So I guess everyone understand, why it is so important to measure trace gas with the great performance at the low concentration range. And now the question is, what should I pick for that monitoring system? Or why you think the HORIBA is good for that applications? Let me address those questions one by one. Let's look at the future again. The GA-370 has excellent accuracy. The linearity is plus minus 0.02 ppm. The thanks to the HORIBA patented technology, the cross-flow modulation, which is a HORIBA developed technology, the HORIBA GA-370 achieved the world-class accuracy with it. Linearity plus minus 0.02 ppm is one of the greatest performance in NDIR. And when you look at the low detection limit, it is 0.01 ppm right here. This is also remarkable performance. I want to explain why HORIBA can achieve that level. Everyone is using same NDIR idea technology, and why you want to say the HORIBA only can achieve that level, low level. There's a lot of trick here. HORIBA want to explain. I want to explain why HORIBA could do that. Actually, that it's because of the cross-flow technology. Let me explain detail. Before I explain the cross-flow techniques, I would like to go step by step. First of all, I would like to show you how the conventional NDIR works. I'm showing the picture. This is the conventional NDIR method. Basically, it has a light source. It has a two light source and a sample cell, reference cell, and the two detectors right there. Okay. And the sample gas travels from inlet to the outlet like this. And the light source goes from the light source to the detectors towards the detector like this. So detectors are reading difference the absorption between the reference cell and sample cell, the absorption of the light source, I mean. So they're looking at some differences between the reference cell and sample cell. But what you're doing is you will keep introducing the sample gas into this cell, and the sample gas will may have some dirty stuff in the sample gas, and that may stick to inside of the cell, and that will cause a drift. So there's some lifetime here because you are 24/7. You'll keep introducing the gas inside here, right? And a drift needs optical adjustment, and also you never know the both of lifetime of the light source or both of the lifetime of detectors. So you may not have the same power from the both of the light source. That may need to be adjusted, right? And also detector sensitivity could be different. So that may be another factor to make error. So there is the balance of the light source power and sensitivity of the detector is pretty important for this case. So somebody has developed the other way to overcome the issue, you know, which contains the one light source, one detector. So you don't have to be worried about the the differences between the two light source and two detectors. And what you're doing here is split the light source, a light power, light like this, and the half of the light goes into the reference cell, and half light goes into this sample cell. Okay, but still, the sample gas is traveling inside the sample cell for 24/7, and that will be the reason could make drift. So sample makes cell dirty, and it's called drift. Yeah, like I explained, and drift needs optical adjustment. And there's some point. You have to split the light power by 50% and 50% equal, and this might be affected by like a vibration in the plant or the laboratory. Even laboratory, you move the analyzer from the place to place, and that could be the reason could make a different alignment, and that will cause the uh, error of the balance of the light split power. So that in that case, you will need some the technical person from the manufacturer to make adjustment. That is the one of the critical problem in this case. And HORIBA cross-flow modulation consists of basically one light source and one cell and one detector. So minimum configuration, right? And also you have another solenoid valves here, and then one source, one cell, and one detector. And what you're doing is you introduce the reference gas, and right after that you introduce a sample gas. So you're switching the gases alternately, introducing the reference gas and sample gas each second. So by doing this, you are you don't have to be worried about the differences between the light source and detectors, and you don't have to be worried about the you know the dirty inside of the cell, because the reference gas is supposed to be very clean and the sample gas is not, right? So while you are introducing the reference gas, it helps to purge inside of the cell, and that will keep the lifetime lasting longer than anybody else. That's how the cross-flow modulation has been, proven for the longer lifetime. So every second you're watching by introducing you're watching zero by introducing the reference gas. So every second you make some small adjustment, it's going to be done. So no zero drift is going to be happening, and then no optical adjustment required. And the automatic cleaning purge for cell is done by this method. And the GA-370, moreover, GA-370 brought cross-flow modulation to the next stage. It is dual cross-flow modulation. In this method, we use two light source and the two cell and the two detectors. I don't want to confuse you because earlier I explained that less components for cross modulation: one detector, one light source, and one cell. And right now we're talking about the two light source and two cell and the two detectors. And here's what we're doing. There's two solenoids. One is for the sample gas solenoid and the reference gas solenoid valve here. So The essential new element in this design is solenoid valve, which alternately directs the sample gas and the reference gas to the one cell of the analyzer. Then the detector reads the difference absorption between two cells, which makes a signal respond like this. So let me. Okay, yeah. So while you are introducing the sample gas into this cell, so the sample gas travels like this way, and it goes in and it goes out. And the reference gas and it goes in this cell, goes out. In this case, the span signal is going to be like this, 0 to span. You're watching the difference between 0 and the span, right? And after that, the span gas, the sample gas travels this way, and it goes in this cell, and it goes out. And the your zero gas, reference gas, goes in this way, this out. So what you're looking at here is you are looking at the span, and right after that, you're looking at the zero. In this case, so you're looking at the span, zero horizontally. This cell is looking at the zero first, and right after that, span. So zero span, zero span. So by using this, it's kind of dual cross-flow modulation can be done. And the reason why we're doing this is because we can get the double signal of the span by using this. We are introducing this span gas into this, and after that we introduce in this. So we could have a double signal from those way. So that is the secret why we can detect that low concentration of the sample gas. So let me summarize this. And as you can see, the both cells are filled by the sample and the reference gas alternately. Since we do the measurement by both cells, this gives us a double amount of IR energy absorption signal, which means it made it possible to measure at a very low concentration. In addition to that, the signal to noise ratio is significantly better because the optical chopper, which tends to introduce a significant noise in a conventional NDIR, is removed in this cross-flow modulation design. Yeah, as you may know, we don't use the chopper motor anywhere because we are just introducing the sample gas in the reference gas alternately, which works as the chopper motor instead. So by eliminating the chopper motor, we can achieve the lower noise level. So in the cross-flow modulation, gas flow rates and cell configuration can be selected, which provide the very smooth modulation to minimize interference. Dual detector system employing the compensating detector located behind the main detector is adapted in these instruments. Let's take a look at the flow schematics. The sample gas is actually split into two lines. This is the analyzer of the schematics. The sample gas travels go in and go into the analyzer detector. But before that, you split the gas into another line, which is a reference line. We purify the reference gas, purify the sample gas to make a reference gas. And it goes into the analyzer detector. So what you are doing here is you are measuring your subject sample gas here, and you are producing the zero at the same time. So you are alternately measuring the sample gas, sample line, and the reference line alternately. This is the the idea from the cross-flow modulation. If you don't use the purifier unit, then that's fine. You just can provide 99.9999% of nitrogen instead of the purifier unit. So that is the that is the reason why we need this utility. Okay. All right. Second reason why GA is great. Online measurement is available. As you can see, it has a great performance on the drift. Says plus minus 0.03 ppm per week. This specification gives you an idea how GA-370 would be a stable, how much GA-370 would be a stable, and for online measurement. So it will be your eyes keep watching your process for like a 24/7, and HORIBA is a system integrator. So we are pleased to offer you a customized solution to meet your site requirement. We can configure the analyzers, order the process flow, and like a sequence, including the PLC, how you wanna, manage your process. And by if you have those major project, we're happy to help with that, and just the full online measurement case. And it is cost effective. Finally, GA-370 gives a great price benefit, and since it can hold up to 2 parameters. As you know, trace gas measurement by NDIR requires long cell, and this fact gives a limitation inside of the room of the analyzer. So that's why other company can offer only the single components for that lowest range, for that low concentration measurement. HORIBA has because HORIBA has a patented technology cross-flow modulation, and it's possible to house 2 analyzer detectors in the box, because we don't have to have that longer cell, because of the cross-flow modulation can detect a lower concentration, and then like dual cross-flow modulation can help us to detect more lower concentration. So that's the reason why we could have the 2 parameters in there. With that being said, all of the electronics operation touch panel can be shared, so we offer it with the great pricing. Lastly, I'm going to show you some friendly user interface. Actually, I am showing that this interface is from a portable gas analyzer PG-350 300 series. But the user interface itself is very similar to this, and as you can see, there's a measurement range, and you can touch this and by switching the measurement ranges. If you are interested in this PG portable gas analyzer, you can take a look at our YouTube channel. We made the webinar and explained about detail those products. So as you can see, the touch panel make it easy for the all operations, and you can switch the range easily, obviously, and you can show you also small measurement trend graph as well if you click. And the calibration can be done with the exact concentration you can enter. And okay, let's wrap up. On the GA-370 uses a dual cross-flow modulation, and a CO, CO2, CH4, N2O, SO2, and siloxane can be measured, and you can select up to 2 parameters from your selection. And it has 1 ppm range, which is the greater repeatability and the linearity, and also drift per week is excellent enough for your continuous measurement. I hope I could show the capability GA has, and thank you for your time today, and I'm happy to answer to the questions.
All right, thank you, Norio. I appreciate that. As it stands right now, we do not have any questions loaded up in the chat box. So I guess with that being said, if anybody does come up with any questions after the fact, please feel free to reach out to myself or to Mick or Tenoria. We'll be happy to answer your questions in any way, shape, or form. As a quick reminder, we'll be uploading this information to our YouTube page at the beginning of next week. If you have any questions about any of our products that we offer for the Process and Environmental Division here at HORIBA, please do reach out to us. We're happy to help in any way, shape, or form. Thanks for your time this Thursday, and I hope everybody has a fantastic day.